So it probably comes as no surprise that the next discussion here will be on two-stage completion methods. And what I mean by that is completion stage methods that are called back when both of the previous stage completions finish. So you have two completable futures, and the two-stage methods will be called back only when both of the previous stages are done. So let's talk about a couple different examples here. The basic way to think of this is an example of composition. So we're going to have some action called back, some dependent action called when both of the previous completable futures finish. And the most obvious method that does this is the then combine method. So as you can see here, then combine is going to take a by function, and that by function is going to be called back when both of the completable futures complete. So you can think of this as kind of like logical conjunction. The by function is called when both of the previous stages complete successfully. You can see this first parameter that's passed in to then combine is a completion stage. So what we have here are two futures. One is the future that's used to invoke then combine. So you would say future, completable future 1 dot then combine. And then the other future, the one that's passed here, is the one that's passed as the first parameter to then combine. So that would be completable future 2. And I'll show you some examples of this in just a second, so it'll be a lot more clear. What then combine returns is a completable future that contains the results of the action. So it's the results of applying this by function to both of the results of the two previous stages when they both complete. So you can basically think of then combine as essentially performing a reduction. It's a bit like a very limited form of a collect method from Java streams, not as generalized, of course, as Java streams, because you can have many items that are collected in a Java stream. But in this case, it's two items that are being joined together. So it's kind of like two streams coming together to form a single stream. We typically use then combine to join two paths of asynchronous execution. And let's take a look at an example. This is an example you can find in my EX8 folder in my GitHub repository. So we're going to have, in this case, we're going to have two completable futures, comp F1 and comp F2. As you can see here, comp F1 is going to be a completable future to an asynchronous computation that multiplies two big fractions together in the background thread from the common fork join pool. Comp F2 is going to be a completable future to the results of performing division on two big fractions. So comp F1, comp F2, they both get kicked off. They're both running asynchronously in the background. And then what we're going to do here is we're going to call the then combine method on comp F1, passing in comp F2 as the first parameter. And there's no particular rhyme the reason to which one comes first. I could say comp F2 dot then combine and pass comp F1 as the first parameter if I so chose. And what we're going to do in this particular case, just to be concrete, is we're going to add the results together of those two other asynchronous big fraction computations. So we're going to have the asynchronous results of multiplying two big fractions, the asynchronous results of dividing two big fractions, and then we're going to add those results together using big fraction : add. And when then combine is called, of course, it's going to return a completable future, and that completable future, when completed, can then be used in a fluent chain. So you can see here what we're going to do when we're all done with adding the results of those two asynchronous computations is we're then going to go ahead and accept them and print the results out. So again, kind of think of this as joining two streams together, two flows of asynchronous computation together to produce a single reduced result. So that's the end of the first part of the two-stage completion stage methods, which in this case was the logical AND version. What we're going to look at next, of course, is going to be the version that does logical OR.